Okay, then we go to uh, the multi-layer cylinders. Okay, same with plain wall in series with different term of R. Okay, it still remain the same. Okay, lucky for plain wall because in the sense that if you look at the equation of plane wall just now, the value of A is the same. Okay? So sama. Jelas sebab tinggi dia pun sama. And dia punya width pun is basically sama. Luckily. Okay. Tetapi okay, yang malangnya untuk silinder A dia tak sama. Sebab dia pakai R kan. Dia bergerak berdasarkan kepada radius. Okay. Dia bergerak merentas radius. So of course the thickness will play the role. Okay, the thickness will play the role, and then you will have each and every layer of A, different A. Okay, and that A is basically A log mean. It's not A biasa. Okay, so you have to be very careful with that lah. Okay, because sometimes you will miss the as long as you have some a good imagination on that particular question so that you can draw and then you visualize that, okay, and then you try to make sure that you count each and every layer that you have in your question. Okay? For example, in this particular figure by Jean Coplis, okay, you have three layer. Okay, maybe A ni will be pipe, okay, pipe, cylindrical pipe. B and C maybe is the layer of insulation, for example lah. Okay, ataupun apa-apalah. Okay, apa application lah. And then you compute each R, okay, because it is still in series. You can always sum up the value of R altogether. Okay, it's just that you have to cater for different K and different E. Just now it's different K but the same A. So A has its own area punya value. Okay, will depend on the radius of that particular layer. Okay, so you have T1 minus T4 over summation of R. So R will depend on RA, RB, and RC. And RA is in between R2 and R1, radius 1 and radius 2. RB is in between radius 2 and radius 3. And RC is in between radius 4 and radius 3. Okay, and so the thickness is matter. Okay, the thickness matter lah. Okay, and of course, we are basically we are assuming that the direction of heat transfer is from inside to outside. Okay, jangan lupa. So from inside to outside, kalau it happen to be opposite macam sebelum ni, so you kena buat opposite lah. Okay. Formula pun dah paste kat rasanya. Okay. We will go with this example. Next example. Sekejap convection ni. Okay, okay. Dia ada lagi 10 minit. Ya, kita habis kat sini kot. buat ni, then after you get the answer, and then we can wrap our session for today lah. We will further our topic next week. A thick wall tube of stainless steel A having K of 21.63, and you have to be very careful with this question because just previously, all this while you've been given the radius, right? For example, this one is the radius. Okay? But in this particular example, okay, they will give you the internal diameter, okay, the diameter. So you have to do something with this value lah. You have to divide it by 2, okay, unless you want to use pi LD as the area punya ni, and this might as well the same lah, okay. And this one you don't have to divide because this one is the thickness, okay. This one sebab dia internal diameter, this one is outer diameter, okay. This one is the thickness or the layer of asbestos insulation, so you don't have to divide that, it remain as it is, okay. So you know that your radius will be 0.0 1 1252 ke apa, okay. Bagikan ni kepada 2, dan this one akan jadi ni kalau bagi 2, okay. And this one dia tak berubah, okay. Dia just campurkan sajalah. Ambil satu kat sini, layer, macam mana nak cakap, temperature, number of temperature lah, sama dengan number of layer plus dengan 1, okay. Then number of interface, okay, temperature sama dengan number of layer minus 1, okay. So ni number of temperature yang ada including inlet ataupun inside and outside temperature is number of layer plus 1. Iaitu you have 2 layer. Kat sini terang-terang dia tulis A dengan B. Dia dah guided dah siap-siap. Kalau dia tak guided, you kena figure out yourself. Okay, A and B, so you have 2 layer plus 1, 3. So when you have outside and inside temperature, you minus, okay, you ada 3 minus 2 tadi, and it leave you with 1 interface lah. So number of interface temperature is number of layer 2 tolak 1. Sama macam yang ini lah. Let's say you ada yang ini, silap, yang ini. This one you ada 3 layer kan. Okay, interface dia ada 2, T2 dengan T3. Okay, temperature dia ada 4. Okay, so 3 campur 1, 4. 3 tolak 1, tolak 2. Tolak 2. Apa ni, 3 tolak 1, 2. Ni, interface dia ada 2. Ni lah ingat ni, tapi tak adalah, ni tak ada nak ni pun, nanti bila kalau you lukis boleh tahu sebenarnya. Tak perlu pun formula ni, cuma just to remind sajalah. Okay. The inside is 800, so this one is quite normal. The outside is 300. So it's normal lah. So it will be the same with the scenario in the figure 8 ni. So dia kat dalam dia tinggi, dekat luar dia rendah. So okay lah, tak ada negatif lah. That's why your value is positive. Okay. So the inside wall temperature is 811, outside is 300. 10.8, and you have this length of pipe of 0.305 meter, and they ask you to determine the heat loss and also the interface temperature. Okay, so easy lah, very easy. Okay. Meaning that with the insulation, okay, with the insulation, asbestos insulation, okay, the value of insulation of 0.24 to 3, you will get 331.7 heat loss. Okay, whereby you don't want that to happen. So you might want to change the material of the insulation. Okay, you can change the material of insulation. Okay, or you can basically um, um, add some more thicker layer of asbestos. You increase the thickness of the layer of asbestos, and you can have what you call um, lesser heat loss. Okay, you reduce the heat loss lah. Okay. That will be the strategy lah to avoid the heat loss. Okay. But you have to be very careful if you associate this with the what you call convection, heat convection. Okay, but because this one is only talking about conduction, no convection whatsoever, so no problem lah. When we have convection and conduction at the same time, it will have impact on that. That is why we have what you call critical thickness of insulation. Nanti kita tengok. Okay. So this is the last slide that I've shown to you. Okay. So it is a system or the process of the steel pipe. Okay, stainless steel hollow cylinder. Okay, ataupun hollow pipe. Okay, which being covered or surrounded by a layer of insulation, okay, or being insulated by the asbestos. Okay. So there will be two layers lah for this. Okay. For this system, there will be two layers. Okay. Okay, oh sorry lukisan saya memang agak abstract Okay, you have A and B. Okay, so when you have two layer, okay, can the sebelum ni I have explained to you the number of layer plus one, the number of layer minus one for number of temperature and for number of interface, kan? Okay. So of course you will have three temperature lah. Okay. Jangan ikut buta-buta equation ni So because we have three equation, three temperature, so of course lah, you just label it by T1, T2 and T3. Okay. So jangan ikut betul-betul equation ni because equation ni are referring to this three layer So because of three layer, they will have four temperatures. Okay, so this one is not valid. T3 lah. Okay, and this one will no longer ada dalam equation tu. So there will be two layers saja. Okay, and you will have only one interface temperature, which is T2. Okay. So you will have the inside wall temperature is 831 is 811. Okay, the outside temperature is T3 310.8 Kelvin. Okay. So they provide you with K untuk A and B. AA is 29.63, AB is 0.2423. Okay, it's quite logical because KB is insulator, so the value of K is a bit rather um, lower lah compared to the KA because it's stainless steel, so the conductivity is a bit high. Okay, and then you have R is equals to 0.0245 R I divide by 2 jangan lupa. This one is internal diameter okay. So outer diameter is 0.0508 over 2 okay. That you have to plus dengan yang ni plus dengan thickness. This thickness you don't have to divide by 2 so let it be 0.0254 okay. So you already have all the information okay. You have this one is you can regard it as R insulator lah okay. So basically dia akan jadi satu yang sama 0.0508 okay. Because 0.0254 times 2 lah dibagi 2 dicampur balik dengan ni jadi 0.0508 okay. So once you have those R okay, it's either you want to use this one as 2 or 2 pi KL lah. Ln R2 over R1 over 2 pi KL. You can use this as well. Okay, then you don't have to compute for A log min lah. Okay, so this one is even easier lah. So if the layer is A, so you're referring to K of A because the L is the same. Okay, so L is 0.305. So L. So this one is Q. So then once you get Q, you will get T2 lah. Okay. So you were referring T2 to either layer A or layer B. Okay. You have Q is T1 minus T2 over RA or Q sama dengan T2 minus T3 over RB. Okay. And you have an overall equation of T1 minus T3 over summation of R. Okay. So by using these two equations, not to use both equation lah at the same time. Pick one lah, because what you want to know is basically T2. So if you ever had T2 in this equation, there's no point of you to get T2 from this equation. It's basically the same one. So you have the option of either you want to use layer A or layer B to get T2. Okay, both will be the same answer lah. Okay, that's why this would be rather simple because you have only one temperature in the interface in between layer A and layer B. Okay, if you ever have other layer, another layer, so the calculation for the temperature might become more tedious lah because you have to determine two temperature instead of only one temperature lah for this example. Okay, Hopefully, by this explanation, very brief explanation, I'm not explaining this in sequence lah. Okay, but I hope this will help you in solving this equation. Okay, and you will get the answer lah. Hopefully. Okay. So, kalau tak dapat tu nanti boleh tanya. Okay.